Okay, so this is an exam review for 1314, exam 2. So we are using the function, and we are going to determine whether the function has a minimum or maximum value, finding the coordinates of the min or maximum point. Well, those min or max values are basically the vertex, so we're going to do our first problem here. So we're looking at h of x is equal to x minus 4 squared minus 9. So it all depends on how your equation is set up. In this case, the setup of this equation, we are going to use the formula where we use the h comma k, because it is in x minus h quantity squared minus k. So for part A, are determining whether it's a max or min, that depends on how it opens up. This has a positive out front, so it's going to be an up because it is a quadratic. If it was a negative in the front of it, it would go down. But because it's positive, we know it's going to be a min, because when it's opening to the positive, the curve comes like this, so it's going to be at the bottom, it'll be a min. If it was a negative out front, we know the curve goes this way, so we're going to have a maximum value right there. So this is going to be a min, and we're looking at the leading coefficient, because the leading coefficient is positive, and we know that it is a degree of 2. It's a parabola, so we can make that a determination. For part B, using our formula of hk, the formula says x minus h, so we know it's going to be opposite of what we see there. It's going to be a 4, and the k will be exactly what you see, so 4 and a negative 9. If this had been a positive 4, it would become a negative 4 here. All right, let's look at question 2. So on question 2, we are given the function f of x is equal to x squared plus 4x plus 3. So this is a different formula. We're still looking to, on this one, we're going to find out whether it's what the vertex is, and then the x and y intercepts, and we're going to graph it. So the first part we need to find is our vertex. And this vertex, this was the vertex up here in that format. This is a different vertex. So with this vertex, we are looking at negative b over 2a, and then the function at negative b over 2a. So we'll first find this part. So we need to know what a is equal to and what b is. So a is equal to 1, b is equal to 4. So our x part will be equal to negative b, so negative 4 over 2 times our a, which is 1. That'll get us negative 4 over 2, which is negative 2. Now we need to find the function of that part. So our y is equal to the function at negative 2, which will be negative 2 squared plus 4 times negative 2 plus 3. So that'll get us negative 2 squared is positive 4. 4 times negative 2 would be negative 8 plus 3. So our value ends up being negative 1. So our vertex is negative 2, negative 1. All right, so now that we have the vertex, let's go find our intercepts. So for part B, we're looking for the x-intercept and the y-intercept. So our x-intercept, we have y is equal to 0. So it's 0 is equal to x squared plus 4x plus 3, going back to our original problem. Remember, f of x, same thing as y. You need to factor this. We use the AC method. I'm just going to factor this. If you need help with factoring, you can go find my video on AC method factoring to help you out. All right, so x plus 1 equals 0. X plus 3 equals 0. You can use any type of factoring method as long as it factors. Solving this, we get x equal to negative 1 and x equals negative 3. So since these are intercepts, it'll be negative 1, 0 and negative 3, 0. And then we need to find the y-intercept. So the y-intercept, x will be equal to 0. So y is equal to 0 squared plus 4 times 0 plus 3. So y is equal to, the two zeros are going to make it go away, so we'll have y equal to 3, so 0, 3. Now these are the parts we're going to use to do our graph. So our numbers aren't too big. We have -2, -1, -1, -3, and 3, so we just really need to go to 3. So we have x, we have y, 1, 2, 3, 2, 3, 1, 2, 3, 1, 2, 3. Now let's graph what we know. We know that the vertex is at -2, -1. We know that the x-intercept is at -1, -3, and the y-intercept is at 3. So we're just kind of going to come down, grab our points, go back up, make sure you put arrows at each one. I'm looking for a sketch, not an exact value. So that is good enough. All right, so our next question, number 3, we are just talking about the end behaviors dealing with the leading coefficient test. All right, so number 3. So we're just using the leading coefficient test to determine the end behavior of the polynomial function. So that way you understand what's going on with that end behavior. So when we're looking at the problem, so let me write the problem out so you know what it is. So we have f of x is equal to 3x to the 4th minus 2x cubed plus 5x squared minus 3x plus 1. We don't really care about all the stuff after the leading coefficient because that's really all we have to look at. So we need to figure out what the leading coefficient is. We need to know whether it's positive or negative. We need to know what the degree is. So whenever we're looking at this, we're looking at the degree and we're looking at the sign. Is it positive or negative? And this is the sign of the leading coefficient. So our leading coefficient is positive, and that's what we care about. And the degree is 4. That's our highest degree in our problem, or our function. We care that it's 4, which tells us that is even. So when the leading coefficient is positive, we care that it's positive this way. When it's even, it's going to go the same way. The evens are like even Steven. They go the same direction as the other one. And it's usually easier to do this if you do this side of the graph and then do that side of the graph. So let's look at problem B. We have g of x is equal to -2x squared plus 7x minus 4. So we're going to look at the same parts here. We care about what the leading coefficient is, and we care about the degree. So our leading coefficient is negative because it's -2x squared. Our degree is even because it is a 2 up here. We care that it is even. Because it's negative, it goes down. Because it's even, it's like even Steven, it does the same thing. It will go the same direction. All right, let's look at part C. For part C, we have h of x is equal to 2x to the 5th minus 4x to the 4th minus 7x cubed plus 6x squared minus 3x minus 8. We don't care about any of that. We only care about the leading coefficient, the one with the highest degree. So again, we're looking for the degree and the leading coefficient. In this case, our leading coefficient is positive, but our degree is odd. Our degree of 5 is odd. So positive tells me it's going to go, it rises up to the right side of it, but with odd, it's going to go the opposite direction, so it will go that way. All right, for part D, we have f of x is equal to -6x cubed plus 8x squared minus 5x plus 3. So again, we're looking for the degree, and we're looking for the leading coefficient. The leading coefficient is negative, so we know on either one it's going to go down, and our degree, again, is odd. So it's going to go down on this side, odd goes opposite, it'll go that way. So what I want you to do is look at this for just 1 second. When it's positive, in both cases, it goes up, odd or even, it's going to go up. When it's negative, in both cases it goes down. This is on the right side. Positive goes up on the right, negative goes down on the right. When it's even, it does the same thing as the other side. So it was positive on this side, it's going up. When it's even, it's going to go up. Think about a parabola. When it's a positive parabola, it goes up. When it's a negative parabola, it goes down on both sides. For the odd, they go opposite. So when it's positive, it goes up. When it's odd, it's going to go down the other way. So they're going to always go the opposite way. When it is negative, it's going to go down, and when it's odd, it's going to go up the other way. So it's always going to be the opposite on the odds, and even, it's going to be the same way. You need to know this because it's going to come into effect when we go do some graphing. All right, let's go look at question number 4. So number 4, part A, we have 2x squared plus 5x minus 12, and it is being divided by x plus 4. So we are looking at doing synthetic or long division. So the first one I'm going to do with synthetic division because it is in this format. The second one I will do slightly different. All right, so if I look at x plus 4, remember it has to be in x minus c format. So really this is x minus a negative 4. That's what it really is. So you need to make sure you have the sign right. You can also understand that you're just going to do the opposite of what you see up into whatever you're dividing by. So we're going to have a negative 4 in the box. And then we're going to pull down all of the coefficients that are here. So we have 2, 5, and negative 12. Make sure you bring the signs. Draw our line. We bring the first number down. Now, if you're missing, like this goes from x squared to x, if we had a missing term of x, we would zero fill. So we bring down the 2. 2 times negative 4 is negative 8. 5 minus 8 is negative 3. Negative 3 times negative 4 is 12. 12 minus 12 is 0. So our answer would be 2x minus 3. That would be the answer to this dividing into that. So for this next one, I am going to do this problem in reverse. If we were given the same exact problem of 2x squared plus 5x minus 12, but this time it was divided by 2x minus 3. So I'm dividing it by what we actually got as the answer because I want to show you long division. You cannot use synthetic division using this format. It has to be in x minus c. So we need to do the same thing, but we're going to do it with 2x minus 3 divided into 2x squared plus 5x minus 12. So we need to figure out, we're doing long division just like you would with numbers. So what times 2x will get us 2x squared? Or if you don't know, you can bring it off to the side and go 2x squared divided by 2x. Well, the 2's would cancel. This would take this down to a 1 and you're ended up with x. So if you don't know, you can bring it off to the side and do some mathematics that way. So I know it's going to be x. So 2x times x would get me 2x squared. Negative 3 times x would get me negative 3x. You're going to draw the line and you're going to change both signs. That's what you do in a regular long division. That's what you also need to do here. The 2x squareds will cancel. 5x plus 3x will get me 8x minus 12. Now 8x divided by 2x, if I come back over here, the x's would cancel. 8 divided by 2 is 4. So I'm going to put plus 4. 4 times 2x is 8x. 4 times negative 3 is negative 12. Draw the line. Change both signs because whenever you're doing long division, you are subtracting them. We just didn't always write it when we do the numbers. And we end up with a 0 here as well. So same problem. I just reversed the numbers we were using, and this one we did long division. All right, let's do a problem that has a remainder. So here is part B. If we have 5x squared minus 13x minus 6 being divided by x minus 3, we are again going to use synthetic division. So I'm going to put my 3 in the box. 5, negative 13, negative 6. Bring down the 5. 5 times 3 is 15. 15 minus 13 is 2. 2 times 3 is 6. And 6 minus 6 is 0. So we end up with 5x plus 2. And that's why. I didn't do the plus 3. All right, let's do the same problem because I want you to know what to do with the remainder if you have one. But this time we're going to use x plus 3. So we'll have a opposite of what we see. We'll have negative 3 in our box. 5, still negative 13, and negative 6. All right, so let's bring down our 5. So 5 comes down. 5 times negative 3 is going to get us 15. 15 minus 13 will get us 2. 2 times negative 3 would be negative 6. We end up with negative 12. So we're always still going down a degree from what we started. We'll end up with 5x going down from 5x squared plus 2, and then that would be for our remainder. It would be, you can put plus a negative 12 or you can put minus. It doesn't matter. Minus 12 over x plus 3 because we're using the x plus 3 in this case. Or you can put the plus here. A lot of times in the homework it'll do the plus and then you do the minus there. So either way you want to look at it. All right, let's go on to number 5. We're going to use the rational zero theorem to list all of the possible rational zeros for the given function. So we're not going to solve it, we're just going to find the possible rational zeros. So this will be number 5. So on number 5, we are looking at, our problem is g of x is equal to 3x to the 5th minus 11x to the 4th minus x squared plus 3x plus 6. On these problems, we don't care about all the stuff in the middle, we care about the ones on the end. So you usually learn this with p and q. So the p is going to be the 6. It's the one past all of the other ones. So it'll be the 6, and the q is going to be the one out front, which is 3. So our factors are going to be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. These are all the factors of 6, and you have to do the plus or minus individually on those. For 3, it will be plus or minus 1 and plus or minus 3. Now to find the actual possible zeros is going to be p divided by q. So in this case, we'll take all of these over these. So first of all, I'm going to take them all over 1. So plus or minus 1, 2, 3, and 6. And now I'll take them individually over our 3 here. So plus or minus 1 over plus or minus 3 gets us plus or minus 1/3. 2 over 3 would be plus or minus 2/3. 3 over 3 would get us 1. We already have that. And 6 over 3 would be 2. We already have that. So we are done. All right, next question, number 6. So in number 6, we are asked to actually use synthetic division in the remainder theorem to find the indicated value. So you actually have to use your synthetic division and the remainder theorem. So we have h of x is equal to 3x cubed minus 7x squared minus 2x plus 5, and they want us to find h at 4. That means the 4 goes in our box just as it is given, and we'll bring down our 3, our negative 7, our negative 2, and 5, our coefficients. Bring down the arrow to 3. 3 times 4 is 12. 12 minus 7 is 5. 5 times 4 is 20. 20 minus 2 is 18. 18 times 4 is 72. 72 and 5 is 77. This is your answer. H at 4 equals 77. All right, our next question, number 7, is solve by using synthetic division to find all the zeros. Given that -3 is a zero of f of x equals x cubed minus 2x squared minus 11x plus 12, and we are given that -3 is a 0. So if they tell you it's a 0, you should get a remainder of 0 when you use synthetic division. So -3 goes in our box, and we have 1, -2, -11, and 12 as our coefficients. Bring down our first one. 1 times -3 is -3. -2 minus 3 is -5. -5 times -3 is 15. 15 minus 11 is 4. 4 times -3 is -12, which gets us a 0. If you don't get a 0 here, when they tell you it's a 0, you did something wrong. Dropping down a degree, we end up with x squared minus 5x plus 4 is equal to 0. Using factoring, we end up with x minus 4 times x minus 1 equal to 0. X minus 4 equals 0, x minus 1 equals 0, x will equal 4, x will equal 1. So all of our answers are -3, 4, and 1. That would be all of the solutions, the zeros that we're looking for. Alrighty. So number 8. On question number 8, we are looking to do an inequality problem. So the problem that we are given is that f of x is equal to 2x minus 3 times x plus 4 greater than or equal to 0. So the first thing we want to do for solving our inequality problem, we need to solve it. We need to graph the solution on a real number line, find some test points, and then find the actual answer. So the first thing we want to do is take that inequality and set it equal to 0. So we'll have 2x minus 3 times x plus 4 is equal to 0. So once we have that factored out, well, it's already factored, because we don't have to factor it, we can just set it equal to 0 and then take each part and set it equal to 0. So here we're going to end up with 2x is equal to 3, divide by 2, x equals 3/2. Over here we get x is equal to -4. So once it's factored and solved like this, now we have our boundary points. So the boundary points give us the ability to figure out what our possible solutions are. So we have a -4 and we have a 3/2. You don't have to put a whole bunch of numbers on there. You just want to find the intervals of the possible solutions. So we're going to put parentheses at each part here. So -infinity to -4 and -4 to 3/2. And then we have -4 to 3/2. And we have 3/2 to infinity. Those are our possible solutions. And now we need to do some test points. So we need to find a point that works in each one. So for this one, I'm going to choose -5. For this one, I'm going to choose 0 because you want to know where 0 lands because that's the easiest one to plug in. And this is 3/2, so I'm going to go past that and I'm going to choose 2. So I'm going to set up some boundary points or some test points to go in here. So you don't have to put the parentheses, you just need to know where they land at. So using -5, 0, and 2, I'm going to plug them into my original equation here, and see if it makes a true statement. So I'll have 2 times -5 minus 3 times -5 plus 4. What you really care about is whether you end up with a positive or negative. So this would be -2, or 2 times -5 would be -10 minus 3. That would get us -13 times negative 5 times 4 is negative 1. Well, negative 13 times negative 1, that is going to be a positive 13. And is positive 13 greater than or equal to 0? Well, yes, it is. So let's plug in 0. So we have 2 times 0 minus 3 times 0 plus 4. Well, 2 times 0 is 0, so we end up with negative 3. 0 plus 4 is times 4. So negative 3 times 4 gets us negative 12. Is that greater than or equal to 0? No, it is not. And then let's check the last one. So we have 2 times 2 minus 3 times 2 plus 4. Well, 2 times 2 is 4. 4 minus 3 would be 1. And 2 plus 4 is 6. Well, 1 times 6 will get us 6. Is that greater than or equal to 0? Yes, it is. Usually in these cases, you're going to end up with 2 up here will work, or the one in the middle will work. You usually will not get all 3, and usually will not get the ones that are next to each other. It's going to be either the outside or the inside. So our final solution, we need to graph this on our graph here. So we're going to have our infinities again, and we'll have our negative 4, and we'll have our 3 halves. So with this, we actually had a greater than or equal to, so we'll use brackets. We know it's the 2 end parts, so we'll use brackets now, because we're not looking at the boundary values. We're looking what's in the middle. We're looking at the actual solution. It will go this way and that way. It'll be negative infinity to negative 4, union with 3 halves to infinity. And that would be your final answer. All right, so for our next problem, we need to just find the vertical, horizontal, and slant asymptotes, or state that they do not exist. So, looking at our next problem, this is number 9. We are given that f of x is equal to x squared plus 2x minus 3 over x minus 7. So we're just going to figure out how to find our asymptotes. So you can learn them with the n and m's, but in class we did them just knowing what was happening. So with x minus 7, we are looking at the valley part of our problem for the vertical asymptote. So x minus 7, set it equal to 0, you get x equals 7, and that is your vertical asymptote. For the horizontal asymptote, we're looking at the highest degree. So it's a y equals, and you have to have it as x equal, because that's what an asymptote is for the vertical. The horizontal has to be y equals. We're looking at the highest degree. So between the top and the bottom of our fraction, we're looking at the highest degree is to the squared. So I'm going to put both up there. So how many x squares do I have at the top? I have 1. How many do I have on the bottom? I have 0. The x squareds will cancel, and I end up with 1 divided by 0, which is undefined. So that means there is no horizontal asymptote. All right, so let's look at a slant asymptote. So slant asymptote, we use synthetic division. Notice they all kind of match. Valley for vertical, highest degree for horizontal, slant goes with synthetic. So x minus 7, remember it's x minus c, so it's just going to be a 7 in our box. 1, 2, and negative 3 from our coefficients. So bringing down our 1, 1 times 7 is 7. 7 plus 2 is 9. 9 times 7 is 63. 63 minus 3 would be 60. On a slant asymptote, we only care about the first 2. So this will become y is equal to, going down a degree, x plus 9. And that would be your slant asymptote. That is all that you need to do. All right, let's look at number 10. So on number 10, we need to, for the given polynomial, state the degree. So we are given f of x is equal to x minus 4 to the 4th times x plus 5 to the 7th. So for part A, we're going to state the degree. Well, that's just 4 plus 7 equals 11. For part B, find the zeros and give their multiplicities. So x minus 4 is equal to 0, and x plus 5 equals 0. X will equal 4, x will equal negative 5. The multiplicity, on the first one, the multiplicity is the degree, which is 4. And on this multiplicity, the degree is 7. So for 4, it's an even. Because it's even, we know that it's going to do two things. It will touch and turn. It'll touch the x-axis and then turn around. On an odd multiplicity, it's going to do one thing, and it crosses the x-axis. So that's all you need to write for me, is whether it crosses or it touches and turns. All right, so let's go look at the big problem. So on number 11, we are given the function f of x is equal to x plus 4 times x plus 2 to the 6th times x minus 1 to the 5th. So that's our original function. We have to do lots of things here. The first one is we have to determine the degree. So the degree, again, we're going to add. So it's going to be 1, because we don't see 1, where it's going to be 1 plus 6 plus 5, which will get us 12. We know that the leading coefficient is positive, and we know that 12 is an even degree, so we know that our end behavior will do that, and that will help us graph it. So that was just finding the degree and finding the end behavior. All right, the second part we need to do is find the x-intercepts, where y equals 0, and we need to find the x or the y-intercept where x equals 0. So with equaling to 0 on this side for y, that means x plus 4 equals 0, x plus 2 equals 0, and x minus 1 equals 0. So this will be x is equal to negative 4, x equals negative 2, and x equals positive 1. These are intercepts, so I'm going to write them as a point. So multiplicity for this one equals, the multiplicity was 1. On this one, the multiplicity is equal to 6. And here the multiplicity is equal to 5. We care if it's an odd or an even number. With odd, we know it will cross. For even, we know it will touch and turn on the x-axis. And for odd, again, it's going to cross the x-axis. All right, so this was, yes, so that was part C. So number of turning points. The max number of turning points, you're going to take your degree minus 1. So that will be 11. So the degree was 12 minus 1. That's your max number of turning points. And for part E, we're going to graph it. So we're going to do a graph here, just using what we know. We don't need a whole lot. Oh, we didn't find the y-intercept. All right, I wrote it down and then I didn't go find it. All right, so we need y is equal to 0 plus 4 times 0 plus 2 to the 6th times 0 minus 1 to the 5th. So y is equal to 4 times 2 to the 6th times negative 1 to the 5th. So it would be 4, 2 to the 6th would be 64, and negative 1 to the 5th is negative 1, and that will get us negative 256. So 0, negative 256. Now, we're not going to make 256 hash marks. What we're going to do is do our x and do our y. And we need a few hash marks, but we don't need negative 256. So we're going to put negative 256 down here, and we'll come catch it down there. Otherwise, we probably need, we'll go ahead and make about 7. We don't need that many because our numbers are not that big for our intercepts. Let's just go really about, we have a negative 4. Let's go about 5 of them. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so marking what we know, we have a negative 4, we have a negative 2, we have a positive 1, and we have our negative 256. Let's put that right about right there. So What else do we know? We know our graph starts like this and it ends like that from our end behavior up here. That's what we need that for. And then these will tell us what we're going to do. At -4, it tells us that we cross. So we're going to come down. At -2, and these don't always go in order, so be careful. At -2, it says we touch and turn. So we're going to come up, touch it, turn, come down and grab our y-intercept, and at this one, at the 1, it will cross again. So there's your graph. And that's all that you need to do. It's just a sketch. Just make sure I can see all your curves. All right, we've got one more problem. For our polynomial, so this will be our last one, we are given an f of x is equal to x minus 5 over x plus 2. So on this one, we got to worry about asymptotes. We have a denominator. So the first part is to find the vertical asymptote. Again, that's finding the valley equal to 0. So x equals -2. The horizontal asymptote is about the highest degree. The highest degree on this is x. So 1x over 1x, because we have one of each. That's just going to be 1. So y equals 1 is our horizontal asymptote. And if we have a horizontal asymptote, then we do not have a slant asymptote. So I wrote none on that one. Part B, we need to find the x-intercept and the y-intercept. X-intercept, y equals 0. So 0 equals x minus 5 over x plus 2. Multiply both sides by that denominator. We get 0 is equal to x minus 5. So x would be equal to positive 5. So that means our intercept is 5, 0. For the y-intercept, we have x equal to 0. So y equals 0 minus 5 over 0 plus 2, which will get you -5/2. So our intercept is 0, -5/2. So now that we've found those, we need to graph it, and we need to find test points. So I'm going to start graphing it so I can see where my points are landing and where I need test points at. So the first one I have is I have a x equals -2. I'm going to go 6 on each side. And we'll go from there. All right, so x equals -2 is a vertical asymptote, and that will have to be with dashed lines. Asymptotes do not have solid lines. Y equals 1 is another one. So I'm drawing those. And then I have my x-intercept is at 5, 0. So 1, 2, 3, 4, 5. And -5/2 is about -2.5 for my y-intercept. So 1, 2.5. So I can go ahead and graph this side of my graph because I know where it's going. And now I'm going to figure out what's going there. So I don't need many test points. So for my test points, I need to choose something on this part here. So I'm going to choose 2 to make it easier to graph. I'm going to choose -3 and -4. So it gives me an idea. So for -3, so I'm choosing x and finding a y, and -4, you can just do 1 if you want. So for -3, I plug it into my original. So -3 minus 5 over -3 plus 2. That'll get me -8, and -3 plus 2 would get me -1. That'll get me +8. So I know that at -3, I'm at +8. So I only had 6. I need 7, 8, so I can kind of graph that up there. And you can do it with one of them, but I like to do 2 to make it a little bit easier to figure out what to do with the graph. So -4 minus 5, -4 plus 2, that'll get me -9 over -2, which is +9/2, which is 4.5. So at 4.5, so at -4, I'm at 4.5. So 1, 2, 3, 4.5. And we're going over to -4. So about there, I can graph it, knowing that I will not cross those asymptotes. And there you go. It's just a sketch. You don't have to have perfection here, just sketching it.